All right, in this lesson, we're going to look at our last method for solving systems of equations. We're going to look at how we do this using our calculator. So we're going to look at how we use something called a matrix to solve. With a system of equations, we're going to make something called an augmented matrix. So an augmented matrix has two parts. All right, this part on the left is from all of the coefficients. Okay, so you can see if we look at this system set up on the left side, we've got 5, 3, -2. And so do we have in the matrix. And then same thing here, we've got the invisible 1, 2, 3, 1, 2, 3, and then 3, -4, and +1. Okay, now the thing is you want to make sure that your system is in standard form. That means it needs to be x, y, z, and then equal sign. Okay, so all of your variables in alphabetical order before the equal sign. And then the other part of an augmented matrix is this right hand side. Okay, that right hand side right there, that is your constants. Okay, that was what we equaled in our system right here. Okay, and so we got that 1, -1, and +10. Okay, and we keep everything in order. Now, that dashed line, we use it when we handwrite our matrix, but when we put this matrix in the calculator, just so you know, we're not going to see that dashed line. All right, so let's practice setting up an augmented matrix. So we're going to write an augmented matrix for the system, and we're going to state the dimensions. So with this system, remember we want to be in standard form. So looking at my first equation, that is not in standard form. I need it in alphabetical order with all my variables before the equal sign. So I need to switch that up. I need to change it to -2x +1y = 1. And then nothing's changing in my second equation because it was already in order. Okay, so I'm going to pull my coefficients to make the first part of my matrix. All right, so in my first part of my matrix, my x's were -2 and +1. My y's were 1 and 3. Okay, and now we need to do our constants. Our constants, the things that we equaled, were 1 and 12. Okay, so we're going to write a 1 and a 12 on the other side of the line. All right, so this matrix has 2 rows, okay? Row 1, row 2. That stood for my 2 equations. And then it has 3 columns. Column 1, column 2, column 3. So this is called a 2 by 3 matrix. That's its dimensions. Okay, so it's rows and then columns. All right, so let's try another one. So once again, I see that this is not completely in order. That top equation is out of order. The z is on the wrong side, so I need to change that up. So when I rewrite this, 3x is good, -4y is good, but that -2z is supposed to be on the other side, so we have to change it to a positive. So this will be +2z = 7. All right, and then everything else is staying the same in my other equations. I'm going to hold any places with a 0 that I'm missing. So I've got 9x + 3y. There's no z, so I'm going to say 0z, and then = 3. And then on my last one, I've got 2x + 4y - 1z = 2. All right, so remember this equal sign is kind of like that line for my matrix. So on my left side, I've got for my x's 3, 9, and 2. My y's are -4, 3, and 4. My z's are 2, 0, and -1. And then on the other side of my equal sign, I've got 7, 3, and 2. So this matrix here has 3 rows and 4 columns. So it is a 3x4 matrix. All right, so that was just setting them up. Now let's talk about how we can use that matrix to actually figure out a solution. What we're going to do with the calculator is we're going to ask the calculator to find something called the reduced row echelon form. And so we talked about Gaussian elimination back when we were going over the elimination method. And with Gaussian elimination, that was when we wanted our equations to be staggered diagonally, right? Gaussian elimination is something that's kind of used to make reduced row echelon form. In reduced row echelon form, we want the numbers on the diagonal on the left-hand side of that line to be ones and everything else to be zeros, because this is representing the equations after we have performed all of those eliminations. Okay, so in this first equation, that top one, it is saying that x is equal to negative 1.4. All right, because remember that first row was where my x's were, my second row came from my y's, and my third row came from my z's. So that first one, since x is the only one that has a number that's not a zero, is saying x is equal to negative 1.4. My second row, 1 is the only thing that's not a zero in the middle, which is my y. So this is saying 1y is equal to 5.2. And then my last one, z, is the only thing that has a number that's not a zero. So this is saying z is equal to 1.6. Or sorry, 16, not 1.6. And so that's how we know our solution. We perform those eliminations on it. And your calculator can do that all like instantaneously. We just have to give it the right commands, all right? So here's our steps for how we do this. We first want to make sure we write our augmented matrix, all right? So like on a piece of paper, a whiteboard, you want to write it down so you can actually see it, all right? Set it up, make sure everything's in order, put zeros where you need them. And then on the calculator, we're pushing the buttons second, and then the button that says x to the power of negative 1, and then we're going to move over to the right. And then that's going to bring us to a menu where we want to select option B, RREF. Okay, RREF means reduced row echelon form. Okay, it's short for reduced row echelon form. And then after that, we're going to type in our matrix. Okay, so let's walk through those first 3 steps. We're going to look at example 3. My step 1 was to write my augmented matrix. Okay, so when I write my matrix, remember that if I don't see a number, my invisible coefficient is 1. If there's not a variable at all, it's a 0. So for my x's, I have a 1, a 2, and a 1. My y's are 1, 3, and negative 1. My z's are 1, 1, and negative 2. So remember that all came from in front of these variables. Okay. And then on the other side of my line, I've got, I'm just going to make this a solid line. I've got a 2, a 3, and a negative 6. All right, so we wrote our augmented matrix. Next, we're going to push our buttons to get the RREF. Okay, so I'm going to show you what this looks like here. So we're going to push second, and then x to the power of negative 1. You'll see a list that has A, B, C, D. Okay, we're going to go to the right. And we're going to go either down or up until we find option B, RREF. And we're going to select that. All right, so now we need to type in our matrix. So to enter your matrix on the calculators I have in my classroom, we press alpha zoom, and then we choose the size of our matrix. Okay. So I'm going to press alpha zoom. And it's going to bring up a little menu. Yours will look a little different than mine. But what I want to do is I want to fix the size. I want to tell it how many rows and columns I need. So this matrix here, this was 3 rows and 4 columns. Oops. So I'm gonna change my rows to 3 rows, I'm going to change my columns to 4 columns, and then I'm going to go to OK and press enter. Now on your calculator in the classroom, there's going to be a bunch of zeros in these spots. And all you got to do is just change the zeros to the numbers that we need. Okay, so I'm going to pull back, look at mine. I need across the top 3 1s and a 2. So 1, and then I'm going to use my arrow to move over. 1, 1, 2. So I'm just using my arrows to get where I want. My next row is 2, 3, 1, 3. So 2, 3, 1, 3. And then my bottom row is 1, -1, -2, -6. 1, -1, -2, -6. Make sure 1, -1, -2, -6. Okay. And then once that's done, I'm going to press enter. And so you can see it gave us over here on the right hand side a new matrix. This is the matrix in reduced row echelon form. We can see our 1s that are on the diagonal of that little 3 by 3 on the side. And then on the right hand side it says -1, 1, and 2. So I'm going to draw that over here. So this has turned into 1, 0, 0, 0, 1, 0, 0, 0, 1. And then on the right hand side we have -1, 1, and 2. Alright, so these right here are my solutions. Okay, so this first row is saying that x equals -1. The second row is saying y equals +1, and the third row is saying z equals 2. So my solution is -1, 1, and 2. All right, and then that's it. Okay. So there are going to be some times when you type these in and something weird happens. Okay, we don't get that reduced row echelon form. Okay, so these right here are after I did it in the calculator. After I typed in RREF and did my matrix, it gave me something that looks like this. Okay, if you type in your matrix and you get a bottom row that looks like this, okay, all zeros right here, and then a number right here. All right, so this is saying 0x plus 0y plus 0z is equal to 1. Well, remember 0x is just 0, same thing for 0y and same thing for 0z. So this really just means 0 equals 1. That is false. So that means this is a no solution system. Okay. Now let's say you did RREF, you typed everything in the calculator, and this time it gave you something with nothing but zeros in the bottom row. Okay, so remember this means 0x plus 0y plus 0z equals 0. So this really just means 0 equals 0, which is a true statement. So this is an infinitely many solution system. All right, so once again, that is after you've put it in the calculator and pressed enter. Okay, that's what your answer systems look like. Okay, make yourself a note. This is what they look like after pressing enter. Okay, all right. So that's pretty much it. As long as you follow your steps, you're going to get these. And now you just need to do your practice.